Hello guys, this is Miss Scott, and today we are going to start chapter 4. The first section is apply triangle sum properties. And by the end of this video, you should be able to answer the question, how can you find the measure of the third angle in a triangle given the other two angles? And I'm guessing you probably have seen how to do that in the past. Before we start talking about that, we need to make sure we know how to classify triangles, and there's two ways you can do that. The first way is by the types of sides, the second is by the types of angles. So first of all, if you have a triangle with 3 different side lengths, we call that a scalene triangle. If you have a triangle with 2 sides that are congruent, that's called isosceles. And in an isosceles triangle, where the 2 congruent sides meet is called the vertex. Okay, the third type is if all sides are equal. We call that equilateral. All right, so those are the 3 types to classify by the types of sides. You can also classify by the types of angles. So if a triangle has all acute angles, so if this angle and this angle and this angle are all less than 90, which in this picture they are, we call that an acute triangle. Okay, if a triangle has a right angle, we call that a right triangle. And last but not least, if a triangle has an obtuse angle, just having a hard time picking out a color here. So many options. All right, so if it has an obtuse angle, we simply call that an obtuse triangle. And it turns out that triangles can also be equiangular. So actually let's do blue because it's very similar to equilateral. So if all 3 angles are the same measure, we call that equiangular. Very similar to equilateral. Okay, so now let's look at a couple of examples here. We're going to sketch and properly mark and label the described triangle. So number 1 asks us to sketch an obtuse isosceles triangle ABC with vertex angle at C. So I'm going to start with the obtuse angle, and I know the obtuse angle has to be C, and I'm going to say it's 110 degrees because I know that's obtuse if it's more than 90, and it doesn't matter where you put A, B, and B, but I'm going to put them on the left and right. So that would be a sketch of this information. All right, now we're going to do an equilateral, equiangular triangle DEF with a perimeter of 12. So here's triangle DEF, and I know it's equiangular, so I'm going to put some arcs there. I also know it's equilateral and that those 3 equal sides have to add up to 12, so each of these has to be 4 centimeters long. All right, so I've got all the information in one picture. Okay, let's move on to example 3. So we're going to classify this triangle by its types of sides. So we have to figure out either if it's scalene, isosceles, or equilateral. They don't tell us the lengths of each sides, but we do know where the 3 points are. So we can use the distance formula from chapter 1 to figure out the lengths of each side and then compare them. So first of all, I'm going to find the length from P to O. So this is my x1 and my y1. This is my x2 and my y2. So from P to O, we end up with -1 minus 0 for x1 minus x2. And then we'll square that. And then we're going to do 2 y1 minus 0, which is y2. Square that and take the square root of the whole thing. So -1 minus 0 is -1. -1 squared is just 1. 2 minus 0 is 2. 2 squared is 4. So for PO, we get the square root of 1 plus 4, which is the square root of 5. And if you plug that in a calculator, it's going to give you about 2.2. So there's our first side. All right, let's go ahead and do that a second time. So I'm going to erase this stuff. And now let's focus on side OQ. So I'm going to say Q is my x1 and my y1, and I'm still going to keep O as my x2, y2. So from Q to O, we're going to plug into the distance formula. X1 is 6, x2 is 0, so 6 minus 0 squared, plus y1, which is 3, minus y2, which is 0, squared, and then we take the square root of the whole thing. So 6 minus 0 is 6, 6 squared is 36, 3 minus 0 is 3, 3 squared is 9. And if we add those together, we get the square root of 45, and if you plug that in a calculator, you're going to get about 6.7 for that next side. All right, last but not least, one more time. Let's find the distance between P and Q. So I'll say P is my x1, y1, Q is my x2, y2, and let's plug into the distance formula to find from P to Q. All right, my x1 is negative 1 minus my x2 of 6 squared, plus my y1 is 2, my y2 is 3 squared. Take the square root of that whole thing. So negative 1 minus 6 is negative 7. If I take negative 7 and square it, I get positive 49. 2 minus 3 is negative 1. Negative 1 squared is positive 1. Add those together and you get the square root of 50, which is about 7.1. All right, so if you notice, this side, and this side are all different lengths. So that would be a scalene triangle. Alrighty, we did it. Okay, flip to the next page of your notes and find, actually this is on the bottom of the page. The triangle sum theorem is something you've probably seen before. If I call this angle 1, 2, and 3, it turns out that if you add those measures up, so the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, those add up to 180 degrees. And that is always true. Theorem 4.2 might look new to you. This is kind of an interesting theorem. It tells you that the exterior angle, or the outside angle, if you know that these two angles, you can find that third one by taking the measure of angle 1 plus the measure of angle 2. That's actually going to equal that outside angle, so the measure of angle 3. And we're going to look at examples of each of these down below. All right, so in example 4, I notice that I have all interior angles. So I've got this angle x, and I know that this means that's 90 degrees. So I can add up x and 90 and set that equal to 180. Or in other words, 2x plus 90 is equal to 180. And then we can just use our algebra skills to solve this. So we end up with 2x equals 90. And if we divide 90 by 2, x is 45. All right. Now let's look at one using that exterior angles theorem, which tells us that we can just take these two non-adjacent interior angles, the 70 degrees and the 88 degrees, and set that equal to y. So if we add those, we get 158 is y. Now, if you didn't remember that exterior angles theorem, you could do this a second way. We know that these three angles inside the triangle, the 70, the 88 degrees, and this, that has to add up to 180. So I could take 180 minus the 70 and minus the 88, and that would leave me with 22 degrees for this angle here. And then that makes a linear pair with y, so I could take 180 minus that 22 degrees, and I'd still end up with 158 degrees. So if you don't remember theorem 4.2, use that you know that the three angles inside add up to 180, and then you can use the fact that a linear pair also makes 180 to find that exterior angle. All right, guys, well, thank you for watching. Don't forget to like and subscribe to my channel. If you have any questions or comments, you can leave those down below. All right, we'll see you guys next time. Take care.